Just getting ready here. Waiting for people to trickle in. Welcome, everybody. Again, feel free to say hello in the chat. We're going out to Facebook and YouTube and Twitch today. Just getting set up here. It's a little tricky being on the road, getting things arranged. A little tricky. Put a little weight on this tripod. Let's see here. Okay, let's just see how we do with this. Hello, everybody. I hope you're having a great Saturday. I am here in Niš, Serbia, and we're going to be talking about weather balloons. We were hoping to see a launch of the government weather station's 4 times daily Radiosonde balloon, which would be launching at 45 minutes before the top of this hour. But at the request of the Met Office, we're going to delay the actual viewing of the next launch to tomorrow, Sunday, at the same time. So instead today, I'm going to be teaching you all about how the balloon works, how the robot works, and how their antique weather instruments are still used today for standard regular precision data recording of the weather as backups to the modern set of instruments. And after the balloon's flight, we'll hopefully have had a chance to track it live on a map. Amateurs are running a network of receivers that tracks weather balloons. And so hopefully we will get a chance to use that site. So bear with me. I'm just getting my setup here. Let's see. Be with you in just a few minutes here. This is tricky. I just added a tripod to my setup as it's gotten increasingly complicated to be streaming while traveling. Just got home from a trip to the copy shop, copy as in print shop, to print out a bunch of the documents, the manuals for the old weather instruments that I would have normally shared with you on screen. But since my laptop is being very intermittently crashy, we're going to be doing this all from my phone, and we're not going to rely on the laptop. So I've got printouts of everything, an old-fashioned way for us to look at the information, though we may try and run the laptop until it crashes. So stand by here with me just a few minutes as we wait for people to come in, and I tidy up here to get everything set up for the stream. I need to make sure my phone has power, etc., etc. Mess is hidden. we've got some good things to look at here today. Feel free to say hello in the chat. I will see the chats, and other people will as well, and you can ask questions. See, here we have the sales brochure for the robotic weather sonde. Actually, that's just the regular weather sonde. So let's get some lights on here. That's a little better. And let's see. We will pull up see if my computer can. Let's go to Meteomodem's website, and we'll share the laptop screen in a minute here. So the Radiosonde is a weather balloon, and that is used by government organizations all over the world. And that's what we'll be talking about today. That light is not helpful, is it? That's better. So let's begin officially here. My name is Dan Bowen, and you are with me here in Serbia, the city of Niš, Serbia. And this is my long trip this winter. And I was just wandering through the city park a week ago and stumbled across this big green shipping container type thing. Let me see if I can show you a picture of this. Yeah, there we go. So this thing here, where is it? Yeah, so I came across something that looked like this, which I imagine you wouldn't recognize from any other random industrial thing, but it is indeed, it is indeed a robotic weather balloon launcher. Normally, these weather stations will bring a balloon out and a little weather transmitter and release it into the sky by hand. But in the last 10 years or so, companies have been innovating so that it reduces the work that a person has to do to make these robots that launch balloons automatically. And that's helpful because the balloons have to be launched either 2 or 4 times a day in all weather. That's rain, shine, hail, snow, fog, freezing weather, baking deserts. And they have to do this from about 1,000 sites around the planet, 2 to 4 times a day. So it helps a lot to have this robot doing the job for you. Hello, Lee. It is cool. Yeah, that's fantastic. It is. So let's take a look at the operation of this device. Now, we can't be there today, unfortunately, which is unexpected, but we can talk about it, and we can actually try and track the data live coming from the balloon that will launch in 1 minute. At 15 minutes past the hour, the balloon actually gets launched, and you can see it. It looks like this here. Let's see if we can get that. Oh, I can't move that over. Yeah, you can see there. That's what it looks like. It actually rolls a flat cover off of this cylinder, and a little white balloon pops out the top and flies up into the sky. I think there's a video of it here. Is this the one? No, that's just a add copy. I think there was one of the launch. Maybe not. Let's flip through this video. It may show a live launch. But this is from the company Meteomodem. And you can see these are all over the world, as I had mentioned, which makes it much easier to get balloons launched. Here we go. Nice little montage of balloons being birthed out of these chambers. This company sells, initially just sold the little electronics box that gets launched out of these things. And right now, 15 minutes after the hour is when the balloon is launching. About 3 kilometers north of me in the Niche Fortress, the balloon is popping out of the Robotsonde launcher. Let's go take a look at the actual, what the actual Radiosonde looks like here. We'll bring up a little document. Yeah, there we go. So let's enlarge this. So this is a Radiosonde, and you can see here on the right, that's what it looks like. You can see a person holding it in their hand, and it looks sort of like a little styrofoam hamburger, but you can see that off the left-hand side, there's a diagonal stick that comes out of the side, and that contains a little temperature sensor on the end, and in the middle, there's a humidity sensor. And they refer to it as a bestseller product for PTU and wind data. And PTU is meteorological terminology for pressure, temperature, and humidity. The U is humidity, and I'm not sure what the etymology of using a U for that is, other than it's the second letter. So this device here is pretty lightweight. I'd imagine probably 200 grams. And this is then attached to a weather balloon, which carries it up at about 1,000 feet per minute, or about 5 meters per second, from the ground all the way up to about 30 kilometers in altitude. And I've got some pictures of, I think, of the inside of this robot here. But first, what we want to do is try and get set up for tracking this Radiosonde. There is an amateur website called SoundHub. Let's Google that, where you can look for Radiosondes that launch. And if you are interested in this, they launch at the same time, like the same minute, across the planet. And that means right now, about 1,000 balloons are launching from your country and every country in the world, basically, and Antarctica as well, starting their journey up for about 45 minutes to the lower stratosphere. And that kind of data that comes back from those is temperature, humidity, and pressure. Mostly temperature, humidity, and pressure, coupled with wind direction and speed at every altitude. So let's go to this soundhub.org. And this is a site that has been set up by amateur balloonists that mostly have done ballooning for fun recreation. And now there's been enough of them that have built radio receivers to actually decode these transmissions. This little data signal that comes back down from the balloon is not private. It's not encrypted or undecipherable. It's pretty plainly decoded. And now they have set up this network of radio receivers all over the world to display the location of these balloons every time they go up in the air. So let's, I haven't used this version before. I've used the version of this website that is for amateur balloons in general, but this is basically a clone of it. So you can see the little blue person there is us, and it is on top of niche, N-I-S, or what looks like H backward N-W, pronounced niche. Unfortunately, the nearest amateur radio receivers that would pick up the data signal from this balloon are here, all the way over here in Bulgaria. And that means it's a little difficult to get the signal until the balloon is high enough that it can see Sofia in Bulgaria. And there are mountains here in between at the border. So that means it's like shaded from view until the balloon comes up above the mountains, as you would see it from Sofia. And that angle from Sofia to the mountains to when the balloon would rise above the shadow of mountains means the balloon has to get to about 7 kilometers before it will be on this map. And in terms of feet, let's find out how many feet that is. How many feet is 7 kilometers?
The answer is 22,965.88 feet.
There we go. So it's 23,000 feet. Just to give you a reference, airliners fly at around 35,000 feet. So it's getting up there towards airliner altitudes when it might pop up on this map. Let's just do last hour. And we'll just leave this map open and check periodically. We can see there are already some other radiosondes on here that have flown in the past, but we'll just wait for this. And it's possible it may not show up. It may be blowing in the northerly direction and stay continuously in the shadow of those mountains for the receiver in Sofia, but we'll give it a shot. One of my goals here on this trip is to obtain the parts to build a receiver and set one up here in Niš or near Belgrade to catch Serbian balloons and track them here on the map for people to see. The neat thing about these radiosonde little, hey, look at that. Speak of the balloon, it is here. It just popped in. Beautiful, beautiful. Key. Beautiful. How cool is that, everybody? How cool is that? So I will try and begin all of this for your viewing pleasure. So it looks like it has an ID number on it, M10121140. No idea what that number means, but M10 is the model of the radiosonde itself. M10 radiosonde. Well, this is exciting. I've actually not watched it on the tracker before. Steve Randall yesterday actually told me about it while we were on the stream. So we see here, let's make it a little bigger even for you. On the lower left side of the screen, you see the data coming live from this radiosonde. So we'll go down from the top to the bottom and explain what this is. So at the top there is the climb rate, 4.7 meters per second, which is what I had said, that 5 meters per second is about what we expect of the vertical climb. Next is the max altitude, which at the moment, the max is going to be every time it reports because it's climbing. So it's setting a new max record every time it reports. So we see now it is at 3,000 meters on the left. I'm going to make this even bigger. Yeah, there we go. So you'll see it updates every little bit. And we expect this to get to 30 4,000 meters today, so 10 times what it is now. And we can expect that there in about a half hour or so. So the next line here shows a date. I'm going to increase my pointer cursor for you to see better. By the way, drop any comments or questions in the chat. I will be able to see those and respond. So Lee asks, does that mean airliners have to navigate around a huge number of balloons all at once, twice a day? Well, yes, they do. The balloons do join the population of vehicles in the air twice a day across the planet, and they are factors for potential collisions with aircraft. However, the sky is bigger than you might think. There's actually, in terms of the size of a radiosonde, which is a box about this big, versus the volume of the entire Earth's atmosphere below 40,000 feet, where planes will fly. There's a lot of room in between planes for a hamburger to be flying around. And the balloon itself is not a danger to be run into. It would be like running into a party balloon with your car. Not gonna hurt. The string is basically dental floss. Again, an airplane wing would just breeze right through that string and cut it into, you can hit the little styrofoam box. Again, that box and its contents are designed to be hittable, basically, to not impact the aircraft in a negative way. They're low enough density that, the box will get smashed into bits and pieces, but it can go through a jet engine, damaging the jet engine, and it can hit airplane cockpit windows or wing leading edges without damaging them. There's been, I think, the number of less than one hand counting actual documented airstrikes of planes and weather balloons in the past 100 years. So the odds are low that they will be an actual traffic factor for the aircraft. So I'm just going to increase my pointer size for you. We go to accessibility, cursor size. Oh yeah, can you see that fat pointer? No, it's tiny. It's still tiny. Let me try sharing the whole screen. You see big pointer now? No, it's tiny. But anyway, so we see now on the left that it is still at 4,300 meters. The time here is the latest data point message that I got back from the balloon. And he says, that's awesome. I'll watch for them when I fly at exact times of day. Maybe I'll get lucky and spot one. It is very possible because as they climb higher in the atmosphere, the balloon gets bigger. So you will see this white balloon start at about 3 feet diameter on the ground when it launches. And the balloon will climb to about 70 or 80,000 feet by the time it bursts. The balloon, the whole time it climbs, is swelling larger until when it finally ruptures from swelling. It can be 20 to 40 feet in diameter. So at airline altitudes, you can expect 10 to 20 feet diameter as it's passing through 30,000 feet. And that is visible, as visible as another aircraft would be. So just look for white orbs out there at your window at universal time of the half hour before midnight universal time and noon universal time. And that is the Uh, right now, the Serbian government is doing extra launches, and it does 2 extra per day, one of which is the one now, which is the 6 p.m. launch. And they also add a 6 a.m. launch. And the actual balloon doesn't go on the hour. It starts 45 minutes before the hour, so that it ends its flight basically at the hour that it is officially known as. So at about 30 minutes from now, the balloon's flight will be over at the top of the hour. That is the scheduled time of these flights. So if we continue down the list, we have on the left, we have GPS coordinates. Then we have battery voltage. Isn't that cool? Now we're getting into real data. Transmit frequency, 402.4 megahertz. 400 to 405 megahertz is the international balloon radio frequencies. It is a weather band assigned to all weather agencies for anything they need to send for data. Not only balloons, but whales, whale trackers will be on these frequencies. And weather satellites will send data on these frequencies. Hold on, I need to mute my notifications. This is getting out of hand. So as we continue down, we get real weather data. Look at this. This is awesome. I have to tip my hat to the programmers of this site, SoundHub.org, who have managed to include the decoded data for this here. So we see in the middle of the left screen, we see relative humidity is 53%. The manufacturer is Meteomodem. The next line is how many satellites are visible for GPS. And that's mostly a technical thing. It's basically what it means is your GPS broken or not? And it's fine. There are 10 satellites that the GPS on the balloon can see right now, which is plenty. You technically only need 3 to get a good GPS reading. So you see the temperature next, negative 18°C. It is getting cold, which is normal for the climb up through the atmosphere. The temperature drops continually, lower and lower and lower as you climb until you reach a particular altitude where the temperature starts rising again as you climb. And that they call it that inflection point, where the temperature versus altitude curve starts getting warmer as you climb, is the actual boundary of the lower atmosphere and the next layer. We live in the lowest chunk of atmosphere called the troposphere, and the next chunk up is called the stratosphere. And the dividing line between those two is not a fixed height. It is, by definition, wherever that day the temperature starts warming up again as you climb. And so that is a dividing line called the tropopause. Tropopause. That's the cutoff between troposphere and stratosphere. And we'll actually see that around 15 kilometers, usually 15 to 18 kilometers this time of year, I think, maybe up to 20 kilometers. So, and we'll see that here if we keep an eye on the temperature. I wonder if there's any, oops, I did the wrong thing. I don't think they have graphs for this telemetry yet. But, oops, oh, you know what? I accidentally flipped over to the one that launched in Belgrade, which is the other balloon site in Serbia. Well, that's great, it's being tracked. So let's go back to our niche one, that is the one we want to track here. Yeah, over niche. I want to show you another feature of this website, which is this little purple path here. If you see this, this is the predicted descent. If the balloon were to pop right now this path is where it would fall based on the winds that we know are predicted to be on the way down to the ground. And then this target is where it might land. And amateurs have gotten into the hobby of going to pick up and recover radiosondes. And these are basically little radio transmitters with weather sensors, but they can be reprogrammed to transmit out of the weather frequencies and onto amateur frequencies. And then we can use basically a free tracker for amateur weather balloon flights to play with. And that's become very popular in the world thanks to the work of these people that figured out how to read the data. And that means if you're near enough and you're not behind mountains that are shading your view of the balloon, if you're near enough, you'll hear the data points on this map. You'll see them go all the way to the ground. And then you just drive to that place and you'll see the little white styrofoam box laying in the field. You go pick it up and it's yours to keep. So let's keep an eye here. We see temperature is now -27 C, and my scroll is kind of out of control. Altitude is 6,800 meters, so we've still got lots of height to go. The climb rate is 5.5 meters per second, so we are picking up speed, which is kind of expected as you climb, because the air gets thinner at a rate that doesn't quite to backtrack for a second. The balloon increases in size, and as it does so, it exposes more area to run into the wind, and so there's more drag against accelerating upward. However, the air gets thinner, which means there's less air to be plowing into, which would slow you down. So if this were in an atmosphere that didn't get thinner, the balloon would slow and slow and slow because it would get to the size of a barn and blocking a lot of wind that would hold it back from climbing fast. However, the atmosphere is thinning faster than the balloon is getting bigger. So there's less and less air above it to be holding it back, to be causing it to be plowed into and drag. So you see our rate will vary. It's currently 5.3 meters per second. And we'll keep an eye on the temperature. We might be able to catch when it starts rising. So we see right now in the lower left, -30 C, -29. And our altitude in the upper left is 7.1 kilometers, 7,100 meters. And you see this data is updating every few seconds here. So this is going well. While we're watching this, I'll read a little bit about the Radiosonde itself. But we'll just Google for one for a second. Which is, there's one. Got me like a close up one. No, that's good enough. I'll just throw that on the screen there. So we want the image. And if we check in with our temperature on the left-hand side here, we see it is -33, and our altitude is 7.5 kilometers. So we click here, increase our size. This is the little gizmo that is sending us this data continuously every second. It transmits down to the ground. And when that data gets to the ground, it is recorded on a chart like this. In the old days, it would literally be recorded with like an electric pen plotter as it climbed. But now a computer will generate this data for us. And the dark line you see here is the temperature that we were talking about. And you see as it gets colder as it climbs, colder and colder, and then all of a sudden the temperature starts getting warmer as it climbs. And that, this knee, they call it here, is the tropopause. So let's keep watching our screen here. It's been a little while since we saw an update. So temperature is -33. Altitude still says 7.5. So we may have had a little signal dropout. The latest data packet here shows 38, which is my local time. That is 3 minutes ago. So the radio receiver is missing some data now, and that's common for signals to fade and come back in and out because let me just mute this. Particularly with the radio receiver being so far away, you see there's actually a little green line that shows how far away that receiver is. The green ring shows the 80-kilometer limit, and the radio receiver you see is actually down here in Bulgaria. If we zoom out, we'll see a blue ring, and that is the outer limit of where you could receive the data from this balloon. That is the horizon that the balloon sees from 8 kilometers high. It can actually see 300 kilometers out once you're that high up. And we see at the same time the yellow balloon from Belgrade is flying as well. In fact, I'll bet you a lot of balloons are on here flying, being tracked. I'll bet you a lot around the world. Let me turn off all the ground stations. Hide receivers. Mid time. But there's a lot of these. It does look like there are a lot of these. Hide the names of these things. No. Let's reduce our screen size to get a view here. Yeah, in fact, look at this. In Europe, anyway, there's a huge network of others. Look at this, everybody. These are all the balloons in the air. As we were talking about, these are flying right now. This is the 1800 UTC, the 6 p.m. sounding, all going up into the air. So our local balloon is still not updated. It still says it was 38 minutes after the hour. So let's go up to the Belgrade one and see how it's doing. Is it updating? No, it was also 1938. I wonder if that radio receiver in Bulgaria had a problem, or if this one was 1939. Makes me think maybe my web page is not updating, because they all seem to be, the latitude point was the same time. Let's see, let's click on our little friend, our local friend. There we go. Yeah, we picked it back up. It was an internet problem. So we see the balloon there, Belgrade and Niš, and we'll look at our data on the left again. We'll zoom in a smidge. We see it's now at 9 kilometers, and the temperature is -48. So let me pull up actually today. So this sounding, this sheet here is from today. This was the balloon that launched at 6 hours ago, at 12 UTC. And we can see generally the temperatures should be sort of similar because it's the same day and the atmosphere won't have changed too much. So let's look at the altitude that we see on the live shot and see what the temperature would have been 6 hours ago. So altitude is currently 9.3 kilometers in the upper left corner of our screen here. And on this chart, we see, or we try to see, oh my gosh, that's tiny. So here's 9 kilometers at this little hash mark here. Actually, I'm going to turn this camera around so we can see this in detail. Cross your fingers that this works. This is always a little iffy on the phone to switch cameras. Back camera down. Make sure my tripod doesn't collapse on you. Do you see that? Definitely not aimed very well. Oops. Can you see this? I can't see it. Yeah, that's pretty good. Let's do split screen. Does that leave us anything new? Look at that. There we go. Perfect. Oh. So we can keep an eye on that, and at the same time, we'll take a peek at this. The old-fashioned way, look at overhead projector on the wall. So that was clear. Charging cable. Okay. Can we see? My lens dirty. A little better. So the down here. Okay, so we see here is the sounding chart, and the web page just stopped loading again. I think I'm gonna have to keep refreshing that. Okay, so we're at negative 50 C here. Oh, we got a little delay. Negative 50 C here in the lower left. Altitude is 10.2 kilometers. So we still got lots of ways to go. So let's take a look here. On the right-hand edge, look where I'm pointing. On the right-hand edge are little marks that show kilometers. These little tiny black marks. We see here, let's look where the current balloon is. It's 10.5 kilometers. And I will point that out here. We have 10 kilometers and 11 kilometers. So we see 10.5 would be right along here. And hey, look at that. That was where the tropopause was yesterday. This knee. And the temperature there would have been about, we look on the diagonal lines here for temperature. It's a weird chart. So 10.5 kilometers here. We go all the way down to this dark orange line to negative 50 C. And look at the current temperature on the left side of the screen here. Here is negative 50 C. We have correlation. So that's great. Looks like I'm going to have to keep reloading by hand. It's a beta, after all. Like my mouse pad. It's called the SKUT diagram. This document here is available from the government website. that launches these balloons. So let's scroll down, find our balloon again. Oh, this is a little tough here, guys. A little tough. Try this one. Okay, so we have this is 10.9, and you know what, we can actually mark this. So let's do at 10.5, we're at -50. So at 10.5, we're at 50, which I had a different color for you. Do a big marker, a big fat marker. Somebody say something. Hey. Oh, damn. I apologize. The crackly audio. Cursing us again. Stand by. Just a second. Okay, how's the audio? Whoa, turn that down. Come on. Sorry. How about now? Can you hear me now? Better now? I'm guessing from no response, you're not hearing me. Oh, shit. See, that's tripod problems. Sounds good. Excellent, excellent. Okay, thank you. So let's go back to our song screen. Let's reload. Well, we'll catch this point before we move on. So we see -49.5 at 11.8 kilometers. So 11.8 is here, -49. So that would be, we follow the 50 line up. negative 49 at 11.8, which is about, it's hard to read, sorry, up there. And while this looks like a significantly different temperature, it's not. You have to remember that the temperatures are a diagonal line up this chart, which is not showing on screen. I apologize. You got things to handle here. Oh, this is tough. Yeah, the artifact of using that laptop, we have the blank corner there. Darn it. Well, make the best of this. So anyway, the diagonal lines on the skew T are going this way. Those are actually constant temperatures. So this is negative 50. This is also negative 49, even though it looks much different on the horizontal. So let's reload this again and see what the latest numbers are. And again, this chart is from earlier in today. So the temperatures being similar are expected. So our altitude now is 12.5 kilometers. That would be, let's see if I can get a paper that I can use as a ruler or something. Yeah, here we go. So at 12.7 now, 12 kilometers here, this line, 12.7 would be about here. And so we come over here to negative 50 again. This is 12.7. So the temperature is actually maintaining fairly consistent slope, which we see it did earlier today. So that means the atmosphere has not changed much in the last day. You know, I suppose I could turn my camera on. Hopefully my laptop won't crap out. If my laptop craps out, we will switch to looking at some of the document. Oh, son of a bitch, what the hell, phone? Pardon me. Well, my phone crapped out that time. That's interesting. Let's look again here. So our, let's see, 12.8 kilometers now. We're still at negative 50 C. And we see the prediction here is, let's see if we can zoom in a little bit. Can we change the shape of this? No. A little more. This is just kind of casual stream here. So we can zoom in a little bit to see where it might land when it bursts. So it looks like right now, if it burst at this altitude, it would come down in this wooded looking area. And let's see if I can bring this phone back onto stream or document camera. So it's, let's see, back camera. Bring it online. There we go. There we go. So we'll reload here again. So a lot of the troubles here are because my equipment is kind of breaking down. And so I'm kind of having to make do with cobble together solutions. Like anyway, so your patronage on Patreon would be greatly supported, greatly appreciated to help make all this possible. For example, when my laptop started crashing, I had to buy a tripod for the phone. And the data plan for going out to launch sites is about $10 per launch each time I go out to those. So let's see what our latest. And I want to thank Lee, who is already on board watching. And what you just said something, I think. Have to go for now, but we'll watch the rest later. Cool. Thanks, Lee. I'm one of your favorite science communicators. Great day. Take care. Thanks for watching. So we see our latest altitude is 13.7 kilometers. So we have 13 there, and 13.7 about this line. And our temperature is negative 49 still. Again, you see there's the temperature there. It says negative 50 C. I think we can see that. Can't hardly see that. Let me see if I can swap these pictures around. If there's any visibility. I can't see it like that. Can you still see numbers? You can still see numbers. Yay. Okay, that works. Okay, so that's even better. So we see here 13.8 kilometers. We have, this is the 50 degrees Celsius diagonal line. So we'll plot the negative 50.6 C here. And so we are well into the stratosphere because, well, we didn't write down the numbers here. We saw it go from negative 18, which is negative 18, which is here. We saw it go down to the negative 30s, the negative 40s. Negative 40 is this line, negative 30 is this line, negative 20, negative 10, etc. So the atmosphere and the stratosphere right now, compared to earlier today, is almost unchanged. So let's see where we are now. We're at 14.2 kilometers, as you see here on the left-hand side. 14.2, that's about here, and our temperature is still negative 50. I'll just put a dot, a small x. And the altitude, the ascent rate is still about 5 meters per second, so we have stabilized there. Our battery is doing well at 5.6 volts. We have now 12 satellites in view. And this will actually continue transmitting even off the top of this chart here. This chart only goes to an altitude of about 14.3 kilometers, which is, 16.3 kilometers. So let's reload and get a new altitude, a new reading. Manchester, Failsworth, nice. Nice, Brits. I love your naming. We're now at 14.6 kilometers altitude here on the left-hand side of the screen. Do you like watching my mouse? Isn't that fun? We see here 14.7, and we'll find that on our chart. So there's 14, there's about 14.7. And the temperature down here is negative 51. So this is negative 50, negative 60. And you probably can't see, but there are fine lines in between that represent 1 degree intervals. So at negative 51.4, we actually land about here, which is again about the same place that the line was previously today at 12 UTC, which is the time then it launched. Hey, I can bring this down closer to the table. Might help a little bit. Legibility. I should really move my mouse. So if we do, there you go. A little bit. It's vaguely visible. So now, hey, we've hit 15 kilometers here on the left-hand side of the screen. And let's slide up to 15 kilometers. You know, I never planned on actually charting the charting this live, but this is really fun. I had not planned on this. I'll have to do this again in the future. I didn't realize that this site had the data being decoded. Oh, we're already up to 15.2, so about here, and the temperature is negative 53. So there's 50, then 1, 2, 3. Yeah, we're very closely tracking 12 hours ago. So if you look at that, I'm not just tracing the same line, but the atmosphere is. This is cool. Now, the number to generate the other line we'll talk about is not available right now. That is dew point temperature, and that's probably just calculated on the ground based on the humidity. But the humidity right now is reading 0, which is not correct. So that may be a decoding problem in the software. So let's refresh again and get an update. And there we go, 11, 14, 450. You know what the cool thing is? We're going to get to see this chart published. In fact, it's probably being published right now. Once we get to the top here, it'll probably be on the web for us to download, and we'll be able to check our work against the actual Weather Service's chart. So we're still reading just 15,258. Let's reload again. Again, this chart is called a skew T. Still 15,258. So we've had a little bit of a data dropout, and that looks like we're getting down towards this nice wooded area. Last time we heard, the temperature was, or the battery voltage is 5.59 volts. Looking good. The ascent rate was 4.4 meters per second. And while we wait for the next data packet, we can look at some other things here on this chart. We'll wait just another minute or two. You can see there's a little red, there you see. There's a little red triangle there and a little number. And that is the actual computed height of the tropopause. And if we zoom out, you'll see that that little red triangle lines right up with the inflection point on the temperature chart, just like we said. So let's reload again, see if we get any new data. My laptop has been very politely staying on tonight. It's been nice to have the live data feed. We would probably lose that without the laptop. Hey, look at that. We are coming in now at the top of our chart. New update. 16.1 kilometers. Temperature negative 53.6. So 16.1. Sorry, I already marked here, but negative 1, 2, 3. So we're about here. Oh, about here. So that one. So a little bit warmer today, right now, than it was earlier today, where we see the black line, previous black line, a little to the left there. So that is the end of our chart. That's the end of the data we have access to as well. So we won't be, I don't have more chart to go up on, obviously, and they won't publish any higher. So we will wait for this to go up and burst, and then go ahead and watch for the actual chart that they publish to be released, and then we'll take a look at that on the computer or on my other phone if possible. Yeah, I can't quite tip it in that direction, sorry. Maybe. There we go. Yep. A little higher. This is A4 paper, something I'm not used to the size of. Very tall compared to US letter size. So we see another position report came in. That is 16.5 kilometers. Let's swap this back over there. We'll make this window a little smaller again, so you can see balloons and numbers. Ooh, too small. Perfect. Maybe. Are we still transmitting? I'm not seeing that update. It's just super laggy. There we go. So let's reload again. So click our IMET here. Oh, it looks like we're losing a lot of SONs. So it looks like a lot of SONs have stopped transmitting around the world, which makes sense. They're getting towards the end of their flight. So we are now at 17 kilometers, 17,000 meters here. Our temperature is -58. Our battery's down to 5.53. And the battery, of course, will be declining the whole time. Boy, you know, I'm getting tired of this phone crashing. It doesn't make any sense. I'm glad Lappy is working tonight. So, yeah, go ahead and allow camera. Let's see. Let's put up a new message. Captions. Live balloon data. Check altitude and temperature. Use on the left. Say hi in chat. Smiley face. How's about that? There we go. There we go. And I am going to kill the chat since there's a few people chatting. So you get a little bit bigger. Wow, I look kind of creepy there. We're going to just share that one window. Ooh. And turn my camera off for a second. There we go. So I'm going to eat a little bit of a snack here while we wait. So we're at 17,059 meters now. When was that last reported? That was 4 minutes ago. Let's reload. It's pretzel time, or in the local language of Serbian, it is kikiriki. Pretzel, or peanut butter. Pretzels, kikiriki is peanut butter. 18,000. Negative 58. Getting cold. This is so cool to be able to watch this fly. Tomorrow, we'll be able to do that. We'll be able to see it launch, and then hopefully watch this as it flies as well. So feel free to drop a note in the chat boxes. I should be able to say hi, though probably not from Facebook chats. Facebook doesn't seem to always link up properly. Though maybe I can check Facebook manually. Can I hide my little person on the map? Can I hide that? No, it's all right. But you see where it launched from niche, NW. That is how you say NISH. Where's my live post? Dan Bone is live now. Natalie says, very cool. I suppose I can let you watch me eat. There's hardly anybody out there anyway. I'll turn this creepy light off for the moment. We have Kikiriki peanut butter pretzels. And 3, that is from 1. Still 693. Let's reload again. There we go. Little update. 19,430 meters altitude. 19.4 kilometers. Our temperature has dropped to negative 56. This is nice. Google is showing us the Latin alphabet and also the Cyrillic alphabet for these place names. Gives you a chance to sort of learn pronunciations. How's the Belgrade balloon doing? This is there are two balloon launching sites in Serbia. One is from Belgrade and the other is Niš, where we are now. But the Belgrade balloon is up here. Well, it's right up here on our map. It's up to 20,900. And our balloon down here, our little robot launched balloon. See how that's doing. We'll reload the data. Still 19,430 altitude. We've got an update. 20 meters, 20 kilometers, negative 55.7 degrees Celsius. Battery's down to 5.45. I don't know the type of battery and voltage operating range. But we could compare it to the Belgrade sounding, which used the same type of device. So Belgrade is at 5.63 volts, so pretty similar. Back to Niš, we're at 20.2 kilometers here. Negative 56 C. So, I'll go see if we have the latest sounding published yet. Here we go. We do have the latest sounding before it even finishes flight. Hot stuff. Open a new window for you to watch both, to see both. Share. There and there. So we see our live balloon is still plugging along. Let's reload that. At 20.9 kilometers, negative 56 degrees Celsius. And this is the data that it collected. it automatically published this chart, which is the second one for this afternoon. We were looking at the one from 12 hours ago, and this is the data live that we just copied down. So as I wrote X's on the paper chart here, we were tracing this line for today's temperatures. So let's take a look here up close to see what was going on here. Well, this has got some interesting bits too. So first of all, we'll see where the knee was Tropo at 9607, which is just about the same as it was earlier today. And pardon my random zooming. And we see over here an interesting feature. This is CAPE. And this is the energy that's available for precipitation, basically. The higher this number, the greater the risk of storm clouds or rain clouds is going to be. So a sunny day would be 0. And this is actually, it's not very likely it's going to rain at this number either, which is why you see a little teeny tiny sun icon there. But we see that number, the CAPE of 53 joules, actually is represented here by this red section. This is the altitude that it is having the risk of clouds forming precipitation. You can see that altitude is between 2 kilometers, it's tiny 2 there, and 4 kilometers here. So there was a 2 kilometer thick layer of potential clouds, and out the window, I can just barely see a cloud hanging there in the sky. Let's see if I can just show it to you. Let's see if my phone can handle this. Screen. Back camera. There we go. Let's open our window. And in the dusky twilight, you see there is a little cloud out there between the buildings. So that's just a little bitty cloud layer, but that's the level that was at risk of forming a rainy cloud. So there's not always even a cloud at these layers, but it indicates it's very humid, and it would be, if the cloud were to form there, it would be likely rain. So we saw there was a little cloud there in the sky, and that is probably the level that the balloon detected this red splotch at, which is a warning that a rainy cloud could develop at this altitude. So let's reload our balloon. We're now at 22,000. Negative 56 degrees. So we're still going up. We expect, anywhere above 25 kilometers, we may see this burst. And the indication of burst is that altitude is now below maximum. So we see here on the right-hand end of the altitude line, it shows maximum altitude. And on the left-hand side of the altitude line, we see current altitude. On the visual side, on the map, you will see a little burst poof icon on the little blue line that will tell you a burst occurred here. I'm going to go grab some more water. BRB. Oh, I'm sorry. Was that out of screen? Yeah, sorry. That whole thing was out of screen. But there you go. There's the data, the current data. I wonder if I can just get it to update by clicking that. Maybe not. Just making sure my cameras and everything are okay. What's our latest data here? Still the same point. So as we see here on the SKU-T chart, zoom out a little bit. Oftentimes when the balloon descends downward, it's tumbling, and so the radio reception gets worse sometimes on descent. So we may get less numbers in between updates than if it's already burst. So the dotted line here is dew point. And when dew point temperature gets very close to temperature, to actual air temperature, that means condensation can form. That's why it's called dew point temperature. The full name is dew point temperature. And it means that if the air gets to that temperature, it will form a cloud or fog. Basically, the water vapor will go from clear, just open sky, to cloudy. Little droplets will start to form instead of being invisible vapor. And this chart shows that the dew point was creeping close to the temperature line, and then it drifted farther away. And that is why it shaded this red. And also the second indication that this might have a cloud is that the temperature line doesn't just continue left. This actually got a little warmer and then started getting colder again. And that kind of curve and hook to the right here, there's even little ones in here. That means that the temperature is not cooling as it climbs like it should. And that's also called a temperature inversion, which you might have heard about, where the temperature is warmer below, how does that work? Yeah, where the temperature gets warmer above a colder section of air, it inverts the direction of cooling that it should be going at. So our balloon is still climbing at 24 kilometers. Temperature is -55 C. We're doing good here. Battery is 5.3 volts. Feel free to say hi in chat. And by the way, I do want to thank my patrons from Patreon. They really help make this possible. It's getting hard on the road to afford to keep this stuff going in a quality way. You may have noticed that the polish has been degrading slowly over the past month here on the road, and that is because my tools have started to become more difficult to maintain due to the wear and tear of travel. And so it would really help. It has really helped for these patrons to be contributing. That's what I was able to buy the tripod with, and how I'm afford to do the streams in the field to pay for the data streaming, which is, it's a lot of data to stand for 2 hours outside doing a video stream. So I really appreciate everybody there, and I would love to read them off to you in recognition, if I can pull that screen up. We have Mike Bowen, Sheila Bunch, Ben Lathan, Ken Howard, Sophie Searcy, M. Fong, Ashley Meyer, Robert Quattlebaum, and Steve Randall. Please consider becoming a patron to help me improve the quality of these streams and bring you better information and more balloon educational content. Also, follow me on Instagram, Twitter, and Facebook. Those are, sorry, I'm looking for the links. There we go. You see, I'm basically Balloon Side Dan on all the platforms. I tweet at least once per week balloon science tidbits and pictures and educational little nuggets, and I usually provide the actual engineering or academic document that the little bit of balloon fact came from, so that you can learn more at your leisure. I do these streams every week or two, though this week has had several streams about balloons, thanks to the discovery of this balloon launching station. While we watch this climb, let's go look at the actual balloon. Let's bring all of these. Where were those pictures? Yeah, we'll do these all. Well, we got one. There's that. We've already seen that. That's just another one of those. That. That's the good one. Okay, so bring back our other window. We're still getting data. Let's reload, though, to get the latest minute. Where'd you go? Oh, our climb rate is increasing. Our altitude is now 25.8 kilometers. Temperature's negative 53 C. We're looking good. And we see this was the machine that launched it, the Meteomodem Robotsonde. And you see this flat panel above this cylinder. The flat panel slides along this railing and exposes the balloon for launch there. These masts are for collecting weather data to calibrate the ambient launch site air to the radiosonde, so that the data is calibrated to a reference. And here is what it looks like inside the Robotsonde. So you see here we have a, oh, come on, phone. We have a carousel, And in this carousel are little white flaps. And under these flaps are stored the balloon, the little, excuse me, the little styrofoam radiosonde, and all the string and the parachute. And these just rotate once every 6 hours or 12 hours under this white cylinder, where the balloon is automatically attached to helium filling apparatus and fills in here. And when the balloon is released, it yanks up a little radiosonde and parachute with it. Let's reload again. Oh, 25.9 kilometers. Doing good. We're doing well. Oh, look at this. You see the Belgrade sonde is a little hook downward. That means that's probably started falling. There it is. It is now on its little parachute. Its max altitude was 27.9, and it's falling down to 25.4 kilometers. You see the prediction here of where it will fall down to the landing point that it estimates. Let's look at our local one and see how it's doing. 25.9 kilometers. It's been a couple minutes old. Let's reload. Yeah, still the same data. Still the same data point. Perhaps it burst, having such a long gap. We'll throw up the data sheet for these radiosondes for you to see. What was this one? I've already seen that. Let's reload that data page. I wonder if I can get some background music for y'all. As usual. Still the same. We're still getting a little bit of a lag here. We're now 6 minutes, 7 minutes behind. 6 minutes. I'm looking at the date timeline here. Ding ding. I'm not going to get those files. Let's see if we can get you some background music that's pleasant here. We'll use Kerbal Space Program. Whoops. Oh, don't do that. Never mind. VLC. Let's see if we reload. Still the same. Interesting. No update. Open VLC. Whoa, we're going to get feedback here. Do that. Just loading up a backup camera here. Okay, that's fine. Open VLC. Let's try reloading again. Here we go. Some audio. Last position was received 14 minutes ago. We may be out of signal for this Radiosonde. Yeah. We'll keep watching it for another 5 minutes or so, but it's probably burst and has tumbled or is falling too fast for that radio station or receiver in Bulgaria to pick it up any longer. While we wait, I want to let you know that the music here that's playing is by Kevin MacLeod. And the songs we may go through are Arcadia, Brittle Rill, Dreamy Flashback, Frost Waltz, Frozen Star, Groove Grove, Impact Lento, Sneaky Adventure. These are by Kevin MacLeod at incompetech.com. Licensed under Creative Commons by Attribution 4.0.
The license is available at creativecommons.org/licenses/by/4.0. These are also featured in the game Kerbal Space Program. See, most of the Radiosondes we see here on the left have all of these were the ones launched at 1800 UTC. The same group that the local sonde here that we are tracking was launched for. Yeah, I think we're going to give up here. It's been 20 minutes since we last heard it. We'll take one last look here, see how the Belgrade sonde is doing on its descent. You can see here this curve in the blue. It's almost down. So its altitude is 10,000 meters. So, well, not almost down. It's 10 kilometers. Descending at 12 meters per second. Pretty fast descent. Under parachute, though, it's pretty standard. And we can zoom out and look at the rest of Europe and see how all of those balloons are doing with their big numbers. Let me see if I can zoom out. I wish there was a way to turn off the... Oh, I just saw there's a telemetry graph. Ah, darn. It would have been cool. It's kind of cluttered, though. Let's see what the local sonde telemetry looks like. Interesting. A little glitchy, but yeah, I can't. Doesn't seem like I can scroll into the past either. It's just zooming. So let's see here. Look at that. We see lots of parachutes. Lots of parachutes. They all are on their way back home. Isn't that cool? SoundHub.org. And you should see this kind of a show 2 to 4 times a day at 0 hours UTC, which is midnight, 6 a.m., noon, and 6 p.m. UTC. That's 0, 6, 12, and 1800 hours UTC. So that sonde has been in the air for 1 hour and 45 minutes already. So that's much longer than I thought. Here's the one. Here's our little one that's sort of dropped off of our receiver. See some down in Turkey, both on their parachutes. What a nice view. Any others? One in Finland. Let's zoom out a little more. Some in the US. Yeah. Not many. There are many. There's probably 100 that usually launch in the US, but like I say, not all stations launch at this time of day. All stations launch at midnight and noon, which is 6 hours before now or after now. Any Southern Hemisphere? Yeah, we got an Australian one. Look at that. Still on the rise. Any East Asian? Nope. Canadian? Nah. Greenland? No Iceland. And still, it was a nice flight. Well, thank you all for watching and coming by. I appreciate you visiting. This has kind of been a casual stream. Tomorrow we will be broadcasting live from the actual launch out at the weather complex in Niš, Serbia again. So again, please consider supporting me to improve these broadcasts and bring you more educational content, interesting balloon launches like this, and keep things up for sharing balloon science. So take care, everybody. Oh, consider supporting me on Patreon, patreon.com/balloonscience.